Okay, over to you, Andrew.
Okay, well, being that we're just getting started, we've only got a few of us here now. I'm just going to give it a few more minutes for a few more people to come into the session. And then we'll do my introduction, and then we carry on to the presentation. So if you just bear with us for a few minutes, we'll give everybody a chance. Is there anybody else in the waiting room there?
Not as of now.
Great. I'll tell you what. I'll start the introduction here, and then whoever shows up, and otherwise people are going to watch this on YouTube. So greetings and welcome to everybody. Thank you for all showing up today. I know this one's been long awaited. I've been waiting with bated breath for this one. So welcome to the, let's see, I think this is our fourth installment of the Innovation Speaker Series, where we give innovators an opportunity to showcase what they do and how their innovations can help improve the environment. So today we are going to, we do our presentation in cooperation with the Canadian Environment Network. And of course, we come together to showcase cutting edge emergent technology. Sorry, I'm reading off a script today, so please indulge me. So before we begin, I want to respectfully recognize and acknowledge the relationship that the First Nations, Inuit, and Métis across Canada have with the land of Canadians, all Canadians live on and enjoy. We would like to recognize the RCEN operates on the traditional unceded territory of the Mi'kmaq, the Willis. Sorry, I do apologize. Wolastoqiyik, Passamaquoddy, Penobscot, and Abenaki Nation, or the Winnicki Confederacy, as well as the Innu and the Inuit people. I do apologize. I have to read these off a little bit difficult. This territory is covered by the treaties of peace and friendship, which these nations first signed with the British Crown in 1726. The treaties did not deal with the surrender of lands and resources, but in fact established the rules for what was to be an ongoing relationship between nations. In the spirit of peace and friendship, I greet you all today. It also reminds us that each of the 634 different First Nations communities, 53 Inuit communities, and 8 Métis settlements have a unique history, culture, spiritual, and environmentally sustainable connection to the land that their people and the ancestors have inhabited since the time immemorial. We encourage all Canadians and visitors to these lands to learn about and regularly acknowledge the historic and current relationship that exists between the unceded land on which we live and work and the First Nations Inuit and Métis. We also encourage all Canadians to consider how they can personally contribute to Canada's reconciliation with Indigenous peoples. Thank you. So again, today's speaker is Tim Perrin, and I have a quick blurb here on Tim. So today we are privileged to have Tim Perrin speaking. He's the CEO, and again, all apologies, Tim, because I'm going to really screw this one up. Paráterízo Plus.
Yep.
Oh, good. I'm getting better at this. And Extrudia Canada, who lead a sustainable construction revolution. Tim will take us through how Paráterízo and Plus and regenerative design and build firm collaborate with Extrudia's cutting-edge robotics and 3D construction printing tech, reshaping our building landscape. So rather than butcher this much more, I'm going to pass the baton over to Tim to give us a presentation. So thank you, Tim. Welcome.
Thank you very much, Andrew. So thanks everyone for being here, and for anyone who watches later online. So Paráterízo, before I really begin, Paráterízo is kind of a combination in Latin of generate innovation. That's where the name comes from. It's not just a tongue twister, but what I'll be talking about is the future of construction and integrating technology to build the future today. So a little bit more about me first. So I went to school for carpentry. I didn't learn exactly what I wanted to there. And what I mean by that was, to me, building better was sustainably and more efficient, because I thought we had already dialed in a lot of the structural elements. Yeah, so after carpentry, moved to BC, took a course called Sustainable Construction Management and Technology. That course was amazing. Had no idea what I was in store for, because I really didn't know what sustainable construction was. I thought I did, but I didn't. And it was also one of the only, or at the time, the only regenerative design course in Canada, which is beyond sustainability, which I'll get into a little bit. Right now, I'm a registered energy advisor, and that's what I'll be doing as my day job moving forward. And that's what I was doing while I was focusing on this as well. I'm a FIAS certified passive house builder, and now bringing 3D construction printing technology, which is called 3DCP or AMC for additive manufacturing and construction, to the Maritimes, and one of the only ones in Canada. So let's talk about the reason why. So let's look at some of these percentages here. Well, we need to hit zero emissions by our supplied grid network by 2050. That's something Canada signed, and that's been our goal. We're not on track to do that at all. Meanwhile, 40% of global greenhouse gas emissions come from our buildings. And with that, 90% of our time is spent indoors. So you can see the correlation there. If we're spending all of our time inside, we need to make sure they're the best they can possibly be, but we also need to actually build them, which is, here's some more, honestly, eye-opening statistics to me anyways. So I already talked about the 90% of time indoors, but what about the equivalent of New York City built every month? And I think that's pretty crazy just to think about how much we're building now. It's kind of crazy, to be honest. The global construction output will grow by 42% from 2020 to 2030. 42%. That's a lot. So we're building a lot. So if we're building a lot and we're not improving it, or we're just saying sustainable, we really need to improve how we're doing stuff, because we contribute already in the construction industry to so much of the global CO2 emissions. So much so that it's actually higher than manufacturing or services industries. So in addition to 40% of global energy, 25% of water, and 40% of resources are used by buildings. And we need to cut emissions by 50% by 2030 to meet our climate goals. And for some reason, Canada has dialed it back to 40 to 45% emissions reductions by 2030. And we need to have 3.5 million more homes by 2030 to meet the demand. And I'll get more into this, but this is really key to with the approach that we're taking with 3D construction printing, and also on the climate side with building more efficiently through embodied carbon and operational carbon. So we need to get to net zero, and we can. Why do we need to change? Well, aside from the buildings themselves and the output, we don't have any workers at all. I mean, like 80% of construction workforce is retiring, and that's in the next 10 years. So if that's the case, and we're already, let's say by 2030, 80% of the construction workforce retiring, we need some radical changes, because a lot of the students aren't getting into the trades anymore. And even if there is a one-to-one replacement rate, the people retiring are the experts. They've been doing it their whole lives, and the replacements will be green workers. So we need a new approach that really tackles some of the areas that people are going to school for, like technology sectors and design and engineering sectors, which are all jobs that we would provide with 3D construction printing. Meanwhile, we're also building. So the next thing is the efficiency. I want to get a little bit into passive house in a minute, but building codes, like I alluded to earlier, are largely structural. Not so much, they don't focus so much on efficiency, and they lack a lot of resilience. And case in point, we have codes that that are still in place today that say you need air infiltration through your building assembly. So that's to say, if you were to have a building assembly that was perfect, literally no holes at all, you would need to meet code technically to puncture holes in that just to meet code. Meanwhile, I am an energy advisor. The number one advice that I give to homeowners is to make your home more airtight. You can do that through really easy things and save up to 25% of energy if it's really bad and you've got a really leaky house or building, by going around putting caulking around the trim baseboard, gaskets around the attic hatch and doors and little things like that. But there's a disconnect in what we're doing. It's been there for years. I'm sure many people have heard we need to build more airtight. And then you've also heard from really reputable builders as well. Buildings need to breathe. That's not at all the case. Buildings don't need to breathe. Occupants need to breathe. And that leads me into passive house. Passive house is a lot of building science, and that's something near and dear to my heart. I love innovation, I love technology, and I love building science. What building science is it's just that. It's diving deeper into how everything functions in our buildings, all the materials, how they work together, and taking the whole building as a system and not just one element. So let's say you could build walls, put cladding on that or siding. It's okay, as soon as you do that, that changes what's going on. So we need to understand that. And that's how we improve moving forward, is using some building science and some innovation. And with that is passive house. Passive house was actually developed in Canada in 1977 with the conservation house. If you look on the bottom right, that's the conservation house. The conservation house is absolutely incredible. I think where I absolutely love buildings and housing. I think it should be in our school curriculum and everything. It's just incredible what this house did. And in the late 70s, it was 90% more efficient. Basically, in relativity, you'd lose one degree per day in the middle of winter with occupants in there, with no heat on. So that's how efficient it was. It was so efficient that it caught the attention of scientists, specifically Wolfgang Weiss from Germany. What he did, he came and studied it. He took it back to Germany and they built their codes around there. So their codes are built around passive house, this house on the bottom that many people have never heard of, that people who lived in that house had no idea what it was, just that it was a house, and it's actually changed how we build today. And Germans are known for their buildings. So that's the reason why we're focusing on passive house and having it as a baseline for what we do. Sorry about that. So what's our strategy? Yeah, so let's get into some of the interesting, cool stuff. So on the left, you can see that's 3D construction printing. That's our printers with our partners, Extrudia. And in the middle on the left, that's Protodom. That's the first 3D printed house in Central Eastern Europe. It was a tiny house. We printed that in 21 hours using roughly $8 in electricity in total, which is pretty incredible overall, and roughly $10,000 in material. The bottom left is our vision moving forward. So this is just a visualization, but this is what we see happening in the future. It's well on its way there. But it's not just housing, it's urban environments. So getting the printer smaller, having it surveyed by a drone, and instead of a single input to one printer, we have multiple inputs in real time to all of the printers, and basically they do their thing building and it's not a single input. And that's stark contrast to what we've got on the right, which was largely done here in Canada, stick framing, which is great. We know how to do it. We've done a great job at it. But the problem with stick framing is you're using dimensionalized lumber or materials, 4x8 sheets and regular lumber. So when you got regular lumber, you need to transport it. If you're in a remote site, not the most economical way to do things, and really difficult sometimes. So what we do is have it down to the smallest form possible and print it out using our printers exactly where it needs to go. So we do need a radical change, and it's a paradigm shift. And we're starting with a new approach, which is 3D construction printing. So we'll develop new natural extrusion materials. We're working with UNB's Wood Science Technology Center to develop a wood waste extrusion material. And that's important because right now we're using concrete. Concrete's the largest emitter in construction. We're using a low embodied carbon concrete mix that actually saves roughly 30% more compared to a conventional build overall, which is amazing since concrete is so has so much embodied carbon. But it's crucial that we develop new materials that get certified, and that's what we're doing. And then to build a net positive and regenerative built environment. So I'll get more into regenerative built environments, but net positive is pretty easy to understand. It's quite simple. We've got goals to reach net zero, producing as much energy as we consume. Net positive is producing more energy than we consume. Regenerative is the other side of the equation, is how we interact with society and the built environment around us. So that's the other equation, because you can easily get to net zero, net positive using materials that are extremely toxic. So we need to have some other things in there to focus on this because it's largely overlooked. And then our vision is using zero emissions construction equipment, as well as a zero emissions construction, so on-site and off-site in our prefab facility. That's not for the minimum viable product, or MVP. That's our vision moving forward. So like I had alluded to, regenerative is beyond sustainability. So they're natural systems that renew social and ecological outcomes. So what we're doing now, we were doing right at the bottom, we were doing pretty bad. As long as things were getting built and it was cheap, we were doing it. Didn't really matter what it was. Then we started to pay attention to things, hence asbestos. We started noticing things when things are bad for our health, or we can't reuse it, certain things, and then we started moving up to less bad. What we have in the middle is sustainable. Sustainable is just that. You're not improving, you're not doing bad, it's just there. So you really need to focus on improving and becoming regenerative and having a positive social and environmental impact. And we have a strategy to do this, our little framework that we've designed. This is the vision moving forward. It's still a work in progress, but it's really important to show even a simple visualization like this, kind of the power that it can have. Just looking at the green, if you focus on the green, that's all design and pre-work that's done. This is really important in construction. In industrial and commercial construction, you get a lot of this. You need to where there's such large projects, but in residential, you can buy a plan, go to a builder and say, can you build this? And they say, yeah. And if you hand the money over, that's basically the end of it. But we need to design from the beginning. That approach, you'll get a lot of cost overruns and a lot of change orders with that approach. Sometimes it's needed, but with what we're doing, it's really important and we have to pre-design. So number one is an integrated pre-design. Number two is passive design strategy. I get in depth with passive design, but basically the building envelope and the environment around it, where the sun's at, how much sun we get, the wind, the soils, everything around our environment, how it interacts with that environment. And maybe the most important thing is looking at regenerative frameworks and integrating them. So what you see on the top right is a living building challenge, and that's the most rigorous building standard that we have today, also created by a Canadian from Ontario. And when you look at all these things, it really puts into perspective everything that needs to be looked at that potentially affects you or the environment or the building. It doesn't mean that you need to nail down every single detail in advance and pay so much money. It just means that we're focused on it. So let's say we build a really airtight home and a really insulated home. If we put materials in here inside that are off-gassing all the time, that are really bad for our health, probably not a good idea. So it kind of lets us think first on what we're doing with a lot of the things and maybe areas that are overlooked in the past. And then energy demand reduction strategy. with innovative product integration and integrated technology. So the technology, we've got some more stuff too. Largely that's 3D construction printing. The products, we've got some just incredible things lined up from really amazing companies who've won amazing awards, green product awards around the world, and that are certified in Canada, and that haven't really been used or that haven't caught on yet. Again, fully certified here and tested, but I'm really excited to showcase some of that stuff in the future. And then our vision, of course, net zero equipment and net zero automated construction. So that's in our facility. And then after that, we'll have our on-site module install, and then building commissioning and building manual. The manual is something that is really near and dear to me. When I was in school, one of my professors likened it to what the manual would be when you go to the grocery store and you look at it at a label on basically anything. It tells you all the ingredients. You can find out where it was made, everything. But with our building, even though it's largely often the largest purchase we'll ever make in our life, you could buy a house, be in a different country, have someone build it. As long as you're paying for it, when you get back, it could be built, but you have no idea what it's made up of or anything. So when you run into issues in the future, you really don't know unless you can reach that builder and they remember or they have a record. So it's basically a detailed and easy to understand blueprint of everything, including the materials, what the materials are made up, where they're from everything from the windows, doors, structure itself, insulation, and where things are located. And it's really important because it's not so applicable with 3D construction printing the way that we'll be doing it, but it still could be in certain areas and intersections. But if you, in a regular house, hang up a picture and you've got a vapor barrier or retarder next to that drywall, let's say, you're putting holes in it, which you don't really want to be doing. So just knowing where certain things are, where you can put things, which you can put things anywhere, just planning so you don't accidentally have consequences down the road. And that's the whole point of having a framework to follow, and that's what we'll be using moving forward. So regenerative built environments are very broadly environments that are creating systems and conditions for life to flourish. So the built environment holds immense potential for combating climate change, and it's not just about constructing structures, it's about creating spaces that harmonize with nature and foster a regenerative future. Now let's talk about Extrudia. So Extrudia is our company in Switzerland, an amazing 3D construction printing company that actually printed the first building, printed building in Central Eastern Europe. And that's our first design that's now live in Switzerland, called EcoTerra. And so what we're doing is we're focusing on additive manufacturing in construction. So Extrudia, we want to revolutionize the construction industry through robotics, AI, and automated data acquisition. And we're doing that at the start with prefab. You can see in the middle there, that is Protodom, a small little tiny house that we printed. We didn't print it with this printer, although this is one of our larger printers along with the one on the bottom. But that just goes to show it's just like you think you have it set up, you print, except instead of on a desktop, it's full-sized, either on-site or off-site, which we're focused on off-site at the start. So what do you get with Construction 4.0 or 3DCP, as it's also called, or AMC? All mean this roughly the same thing. Some get more detailed than others, but you get time savings. That's a huge, huge thing. Everything's calculated, and we have job creation and job reallocation. I think reallocation's kind of really important here, where we don't have the workforce that we did have in terms of so many people lining up to get into trades. I'm an example of that. I was in carpentry. I absolutely loved it. I'm not in carpentry anymore, but there's still ways to build. So I went into carpentry because I wanted to build. We just have technology now and different ways where we can. Sometimes it's a health related issue, why people get out. Other times it's money or financial issues. Either way, we'll be creating jobs largely in industries that still let you build, but in jobs that are more in line with the industry today. And then of course, no material waste, and that's huge. What you input into the computer or printer is what's outputted, which if you look at the picture, you can see some cool designs, and really it's limitless, the designs that you can come up with. As long as it's structural, you don't have massive overhangs or something between layers, then you can really design anything. Wave patterns, diamond patterns, it really doesn't matter. The layer lines that you see, so every single layer line, lots of people like that, but then there's other people that don't. So you can, it's a technology. You can add extruder arms or pieces to the equipment to screed it or make it smooth, or change it. And we can also do subtractive manufacturing for drilling holes and whatnot. And as we move forward, we'll be able to add even more things like painting and insulating, all with the one machine. But we're not there yet. But that just goes to show some of the potential that we've got with this technology. And then, of course, constant quality assurance. Again, what you input in the computer is what's outputted. Where there's so much pre-design, this is important. There's really not the insecurities, and there's not the question marks of, is this person going to do this according to plan? Is the printer going to print out what you put in? And as long as you put it in the way that it needs to, and then it's going to be perfect every time down to fractions of a millimeter. So some other benefits is it takes days instead of months to build this way. So there's no molds required, and we can reduce the construction time by up to 70%. And this is a misleading stat. I'm a pretty honest person, so I don't like any really crazy statistics. I don't like to throw those around if they seem too good to be true. And this has been too good to be true in the past. What we've seen with this from other companies. So, and for some context, this is new, but there's companies that have contracts with SpaceX and NASA with hundreds of millions of dollars invested in their technology to do this. And what's happened is, when we're focusing on building, let's say, a single house, what you need to do with the systems that have been in place largely is you need to set it up. So this 50 to 70% construction time isn't the setup. And to set up the big gantry style systems, you need concrete piers. So sometimes it takes days, weeks, potentially months, depending on how many, which kind of takes away from the fact that it's super quick to actually put up the interior and exterior walls. And we actually do the roof as well, which I'll get into a little bit. But that's where the 50 to 70% construction time comes in, where we're doing prefabrication. We will actually realize 50 to 70% time savings, and also on site. We've got a pretty innovative printer specifically for on site that eliminates setup time that I'll talk about here in a moment as well. So we reduce CO2. I did mention this earlier, but we'll cut CO2 up to 30% for every house printed, which to me, that's pretty crazy. Concrete's the biggest emitter. So even when you're comparing that with a regular house that's largely built out of wood, stick framing, it's largely because we don't have well, first of all, the time, the labor, and then no waste at all. And that's how we can do that, paired with the low embodied carbon concrete. And of course, this will be much, much higher in the future when we get additional materials that are carbon sequestering. So enhanced safety and weather independence, just like any prefab facility or offsite construction, it's in a controlled environment. So that means you can work pretty much 24/7. What's cool with this is you don't need as many workers, so you really can work 24/7, just with basically security and someone watching the equipment theoretically. And of course, it's safe. And then we have precision and consistent quality. So yeah, lots of benefits. And then, of course, building faster saves time and money. So we'll start fast. We'll reduce the build time by 50 to 70%. We have a 60 MPa or megapascal concrete mix. So a little bit about the mix. It's really, that's kind of just thrown in there, but that's really important. So 60 MPa, for anyone not familiar, that's incredibly strong. It's almost 3 times as much as you need for residential. It's almost double what you'd need for the worst case scenario in residential construction, which is garage floor, where you got really heavy stuff. So it's really strong material, and it's also concrete. I'll get more into that in a minute, but it's not a mortar. And then, of course, we move in while others are still building, so your home sweet home with zero stress. So what's the process like? It's design. So you pick your design. You can collaborate with us with a pre-design, which I'll show here in a moment, and that's one of them on the bottom. Or we can do a custom design as well. Then transport it, assemble it, and do the finishing touches. The finishing touches always take the longest. What we really focus on is reducing the times and eliminating waste. Where we can do, as you see on the bottom left, we'll do the roof, and that's a Scandinavian style or a steep slope or pitched roof. And we figured out a way to do that printing. So we'll normally, what happens with 3D construction printing is that you get a really strange kind of curved roof, just to print it, to showcase that it's possible and that it kind of tapers into a flat roof. Or you've got a traditional truss system, which is largely what's used with print. If you look at the printer picture, that would be the finished product, and that's what we did with Protodom, and then we'd put a truss system on top. So we're really focused on eliminating as many areas as possible, or putting that into the printer's hands, because that's will really reduce the construction costs and time. Now let's meet the fleet. So the equipment. I touched on the concrete mix. So our concrete mix is called X Mix. I didn't put a picture in here because it's just a concrete bag, but it is an ISO ASTM certified ink. That's what we call the concrete mix or building material. What that means is, in many countries, including Canada and the US, it's a certified material to build with. And that's huge. Some of the companies that started out and that now have contracts with massive international companies, they didn't even start out with their own concrete mix. They were buying a formulated mixture from either a quarry, getting it engineered, or another company. And that costs a lot of money. So having that mix is huge and was the hardest part. It's also a concrete, not a mortar. So the big difference, concrete has the aggregate, the large aggregate, mortar doesn't, and it's structural. So we can build with concrete in Canada. You can't build structural with mortar. And now we've got the X Mix, the second hardest piece, even though both of those are less cool than the actual printers. They're by far the hardest because they need to be perfect for us to print. But we've got our own ink, our own mixer, and then we'll get into the printers. So the DLL 1.2. I think it was 2 slides ago, we had the DLL 1.0, which was kind of an unfinished or stainless steel looking printer that was on the left-hand side of the screen. And that was what printed Protodom. And this is based off of that. We've had a lot of interest from universities, because what universities are doing right now, they see potential in developing materials. And that's what we're doing with Wood Science Technology Center with UNB as well. But the problem is, a lot of the companies are focused on housing. So they're building systems like the DLL 2.0, which don't fit in any of the facilities, or most of the facilities. And then if they do, cost so much to operate it, it doesn't make sense to do a bunch of little tests on materials. So university have shown a lot of interest in our DLL 1.2. It's small, but you can still build walls with it, or you can do small little test prints for materials. The DLL 2.0, it's basically a large size 1.2. It's focused on offsite and onsite, The on-site though is largely going to be for row homes, and something really, really cool that you can do is the design aspect with this. So on the bottom, those are tracks. It's on like on a rail system. You can either add more to it, or you just take the one that's behind and keep putting it in front. But theoretically, that's infinite amount of row homes you could build. But the really cool part, like I said, with the design is you could have a different design as long as it fits within the printing area. Every single house, whether it's attached or detached. That's huge. What you've got in the past for cost savings, for zoning, looks, many different things. It's the same thing, largely the exact same thing with some different colors, maybe a couple different architectural features on the exterior, and then some different flooring choices, wall choices, etc. on the inside. What this allows is design that's attached or detached, and the next one, when it moves along, is completely different. That opens huge doors, and it really doesn't cost much more because we don't have any waste. You're not stuck with panelized systems. So yeah, it's really, really cool. And then the 3.0. So these are under development. The 3.0 is actually fully developed, every nut and bolt, and it's the world's first fully self-assembling gantry style printer. And this is what I was talking about with the setup times. Excuse me. So when you get on site, it doesn't make sense to have concrete piers. It's amazing to test, to showcase what's possible. But in reality and being practical, it really eats a lot of time to do that. So having something that eliminates the setup time really takes advantage of what we're doing here with 3D construction printing. Next is Adapta. That's our dual extruder arm system, largely meant for urban environments. They're smaller, they can fit through an elevator shaft, and that's exactly what we envision for them with the drone, basically communicating with AI on a neural network. And instead of single inputs, you've got the whole thing communicating with minimal to no human intervention, which does sound crazy, but we're there. And that's insane to think about. Black Widow. Black Widow, our arachnid all-terrain dual extrusion robot. It is really cool, but the possibilities are just kind of mind-blowing with this stuff because, like, I think about the Arctic. So how would you build there before? You'd either need to be super skillful, cut down the trees, do it all yourself with the equipment. Everything needs to be either snowmobiled in, or depending on where in the summertime, do it during the summertime. The other option, if you're building more, let's say, modern to today's stick framing standards, you'd need to buy it from a store and deliver it. And in the north or remote areas, you can't do that. So if you can't get there, you need a helicopter or a plane, which isn't feasible almost always. And then you're stuck with panelized or basically set dimensions on all of your materials. So sheet goods and lumber, which doesn't optimize space with what we're doing. The goal is you can use on-site material. We can't build with it right now without approval, but the goal would be to basically send the robots out. They could collect material on site and print with it, which is cool. It's a ways away, but that's the idea. And until then, we'd still need something to go along or to carry it or bring it there. But we do have certified ink to do that as well. So we've worked with quite a few pretty awesome companies, to be honest. LafargeHolcim, Siemens, Sika, and Perry Construction. So they're massive, massive companies. LafargeHolcim helped develop our certified ISO ASTM certified ink. And locally, we've got CFM, Sunny Corner, who will be manufacturing the printers here, and UNB, Wood Science Technology Center, who's helping with the development of new extrusion materials. And this is Ecoterra. So this isn't available in North America at the moment, because we'll be working with a architecture firm based in Nova Scotia called Passive Design Solutions. They're a pretty awesome company, one of the oldest passive design companies in Canada, and they have the first certified passive house builder and consultant that was in Canada on their team. But yeah, so what that means is we'll have something that looks similar to this. And if you look at the bottom picture, so one over from the left on the bottom with the solar panels and the window, that gives a good representation of kind of where or how these things click together. And so that's one half of a panel. So on the other side, you'd have an identical piece that literally clicks together. And theoretically, you can keep going on infinitely lengthwise. And that's how this will work. So I'd like to thank everyone for listening. I got a couple more slides after this, but that kind of ends what I have to say with this. So yeah, I'll go into rethinking affordable housing. So it's really important for us to address affordable housing. It may not be the #1 strategy moving forward for profit, but I mean, we need solutions, and I think we have this in 3D construction printing to tackle affordable housing, as well as tackle efficiency and sustainability. It's a really great approach. And here in St. Stephen, just the other day, someone died in a public space because they didn't have a place to live. St. Stephen's a small little area, and there's roughly 70 homeless people living here. Like, that's not acceptable. And there's a state of emergency here right now. And to be honest, like, it kills me because I've got this awesome stuff. Like, we could build and house people affordably without hurting the grid at all. Like, it's really, really easy to get to net zero when you build 90% more efficiently, and we can do that today. We just need people to come together, and this is what CMHC said. So they said addressing housing affordability requires collective action and new creative solutions. We need to bring together governments, financial organizations, and other partners, such as developers, to incentivize and help make system-wide changes that address the housing needs of all Canadians. So if you want to learn more, feel free to reach out to me personally at tim.perrin at paráterízo.com. You can call or text me at 506-647-3197. And you can check out the websites at paráterízo.com and extrudia.com. But yeah, so that's the end of this presentation. If anyone's got any questions, happy to take them, or if there's anything else I need to do. But yeah, super excited to tell you guys about this. So I hope you enjoyed it. Thank you.
Thanks, Tim. That was absolutely off the charts. I remember watching it last week, but this you've gone way beyond. This is brilliant. So I put your email address into the chat bar for everybody to connect up with you. Does anybody have any questions? Just unmute and ask away. Don't be shy. Oh.
Thanks. I have a question.
Yep.
Thanks for the presentation. Super interesting. My name's Stephanie Crocker, and we're at Holland College and UPEI creating some courses for the Clean Tech Academy, which is a new initiative. So yeah, when I hear your solution, I think about how to present it to students and how should they think about the feasibility of this option. So there were a few questions I was thinking from that light. First of all, I was wondering, what is it that makes the concrete that you use lower GHG emitting?
Sorry, what was the question?
What is it about the concrete that you use that is lower? You said it was lower embodied carbon.
Yep.
So how is that so?
Yeah, so the ink is, we can't discuss it too much, but it's the common stuff. Like, we can put fly ash and stuff in there as well. We've got some more mixtures, but I can't say too much about it because it's a super secretive process that takes a lot of time, a lot of money to work with. But yeah, it's similar stuff to what we're doing with, let's say, fly ash and whatnot. But there's lots of ways we can get there, and most quarries also have low embodied options. It's just hard to get, or they don't want to do it. So lots of jurisdictions, or not lots, some jurisdictions said it, okay, maybe we should, and people have been pushing, set aside this day of the week, you can order this. This day of the week, you can order that. But yeah, it's nothing groundbreaking. What's groundbreaking about the mix is that we can build with it, and it's super strong with our printers, and it is lower than a regular mix in body carbon.
Okay. And so what's the sort of cost analysis of like that EcoTerra house? What's the cost analysis to build versus like a wooden house of the same size?
Yep. So it's roughly, just in general, 40% cheaper to 3D print a house. And that's just general stats. What I can give you is Protodom, what it actually costs to build Protodom. Protodom, which is a tiny house, took 21 hours to print, 3 days to finish with everything else, including the roof and interior finishes, painting, etc. And that was $10,000 in material, 21 hours to build, and $8 in electricity for the printer to run for that time. So where there's 2 operators, let's say, to get that done, and then just the trades, where it's a small building, it's the regular trades. Where we're saving the money is no waste, the time that it takes to actually build, and then of course we can do the roof system as well. So it's huge in terms of the labor force, and that's a real important thing that we're touching, where we don't really have it right now.
I hesitate to ask this last question, but what is the cost of one of those printers? Like which one? The DLL 2.0.
Yeah, so right now we're working with Sunny Corner and CFM to come up with pricing. So it's not a one-for-one trade-off, because it needs to be certified in Canada. So even if every nut and bolt is done, and I can share an example of this. So in Ontario, Nidus 3D printed a 3D printed house. They bought a printer from a company, the largest 3D CP company in the world. But when they got the printer, they needed to switch everything over to Canadian standards. But with that, it's what we're going to sell the printer for. We need to finalize that with Sunny Corner and CFM. But it's with the smaller printer especially, we're looking at roughly 80,000 for the smaller printer to start, which is way below anyone else to start. And of course, with the 2.0, when we introduce that, it'll be much higher price. For a comparative one, it's around $1 million for a comparative one, let's say Cobot or a company like that.
Okay, I have way more questions, but I'm going to stop now and talk to you later.
Feel free to email me anything, call, text.
Thank you.
You're welcome.
I believe Lena has a question.
Yeah.
Hello.
She's next to me.
My partner.
Okay.
Well, first of all, thank you for the presentation, Tim. That was amazing. I come from an engineering background in architecture, and I'm just fascinating and also a little bit scared of the future of this industry, considering everybody's going to retire. But my question was regarding maybe more the scale of these projects. I was wondering, you mentioned that single components can be printed out. So you mentioned the example of the wall. Are we at a stage where we can build housing, like small houses, but we can still use, let's say, different components and go higher and build bigger? And what's kind of the when it comes to the Canadian code of building code, how does that relate?
Yeah, so that's a great question, and we haven't really, no one in the world has done anything, and don't quote me on this, but I believe above 4 stories yet. I think there was a 4-story one, but no one's done anything it's not it's really new. It's largely an issue. So from your engineering side, it's largely an issue, not with the compressive strength, but a lot of the reinforcing that we're doing right now, it's you're using rebar or else you're reinforcing using the actual ink. So it's not tested and proven yet. So we're not building very high. But I mean, when you think of how we build today, the largest buildings are made out of concrete, and we can get the mix just right. So yeah, theoretically, we can build just as high as any other building. We just don't have any testing done yet to be able to do that. Right now in housing, there's been all kinds of houses. Once people start like learning more and diving into 3D construction printing, there's been so many things already printed and built throughout the world, including one passive house in Ukraine that was 3D printed. But it's all smaller scale right now because it's the easiest to work with, but it's definitely going to literally start reaching new heights soon.
I believe Sandra has a question.
Thanks so much. Really interesting presentation. So what are some of the barriers, I guess, that keep this from happening? Like, do you get pushback from inspectors, like regulations, bylaws, those types of things? Because this would also be a great thing for like Habitat for Humanity houses. I'm thinking they're up quickly. There's limited building that's required for it. What are some of the things that keep you from being able to do this or move this forward?
Yeah, it's the stereotypical stuff. So the construction industry, and this is generalizing, has been unbelievably stagnant overall, especially residential. Like if you look at, I'll always compare it. I know it's a rough comparison, but that's what I learned. So that's what I'll compare it to is the automotive industry. Like where we came from, we're still building 100 years ago. And you can look at a picture, if it wasn't black and white and what the clothes were, like you couldn't tell a difference sometimes. So the barriers are, it's different. I mean, that's the main barrier is it's different. And then also you need an engineer stamp on pretty much everything right now. We can build with our concrete, but it's so different. Like you'll hear stories, this is completely aside from 3D construction printing, just in a regular house stick frame, you'll hear stories of a jurisdiction stopping some builder trying to do a little bit better by putting foam gaskets around outlets and things like that a few years ago. Like just little things. So anytime there's change in construction, you're going to get a lot of pushback. And that's been the biggest thing is it's so different. It's not proven yet. But at the same time, there's been overwhelmingly more support in terms of like, man, can you do this? Is this real? Is this possible? What have you done? Like, how can we do this? So it's been super awesome that way. It's just, yeah, there's always barriers with on, let's say, I don't know, the paperwork side of things that always slows everything down so much. And that's where we're at right now with things too. There's, I can't name names, but I mean, some really awesome people in New Brunswick with organizations that just can't wait to get started with what we're doing and to start testing it because it really is, aside from being cool, which it is, I think, super cool, it's really addressing something we desperately need right now. And that's where my heart is and that's where my passion is anyways. That's why I got into building. Like, let's actually build some things. And then as an energy advisor, it makes no sense. Why am I going into a house that was built last year saying, oh, you need more insulation here, or if you had have done this, and like, let's not slap 60 solar panels on, you could have done 30 or 20 if you had done this, which saved you a bunch of money. So it's just building that way from the start. This lets us leverage the technology from the beginning to save some of those costs. Again, it's been an industry with not lies, but like it's new. So you want to really kind of tout what you're doing and showcase it. But then you get that 50 to 70% cost savings. And then in real world comes around and you need so much time to set up. That's not a good look when someone's expecting you to come in cheaper and then you're more expensive because you forgot to say, oh yeah, it actually takes weeks for me to set this up, but you'll be left with something really cool. And that's what it's been. It's been a little bit of a bad rap also with some companies not using their technology, so they'll sell it, and basically there you go, great, have at it, have fun. If you need ink or whatnot, let us know. We're here if you have any questions, but it needs to be a lot more integrated than that, especially when it's such a big change. And that's been the largest issues right now. It's just the unknowns from pretty much everyone on how to move forward. But Nidus 3D in Ontario, that was the first 3D construction printed building in Canada, and they worked with Habitat for Humanity on that.
Is there any further questions? Well, Tim, I'd like to take this opportunity to thank you. Absolutely amazing. I've been excited about this from the moment we met. And I would really like to commend you for this, and really look forward to seeing how this all plays out in the near future for you.
Thanks, Andrew. Yeah, I'm excited to hopefully soon showcase this stuff, and then you guys will actually be able to see, come touch and feel why it's different and kind of the approach of with the efficiency as well. And yeah, with that, like the approach really is to touch as many pain points in the industry as we can today. It's not a profit approach, which is important. It's this is what I've noticed throughout my experience. This is what I've noticed we kind of need to do or we haven't been doing. And let's get this to a point where we can address those things. So yeah, if you guys are interested in more, feel free to reach out. I'm on LinkedIn as well, but reach out on email, phone, it doesn't matter. I love to talk about the stuff. If anyone wants to talk about building science too, yeah, that's kind of my jam. So yeah, thank you so much.
Just to let everybody know, this video will be available on the ACCN website in coming days. And then I encourage you to share it with everybody. Share it with absolutely everybody, because I think this is really cool. And, we want to let everybody know about it. And just want to remind you that we have our next innovation speaker series in January. I'm just pulling up my calendar. I believe it is just bear with me a moment. It is January 16th, where we'll be having a company called PlayX. And simply put, they make giant Lego blocks for construction. The best way I can describe it, and they're made out of recycled material. Also coming out of New Brunswick. So I really encourage you to sign up for that one. And again, that would be January 16th. So I thank you all for attending, and I look forward to you attending to our other sessions and reaching out to Tim and asking questions. So thank you again.